All right. Sorry for starting a bit late today, guys. It's gonna be a pretty manageable lecture, I think, today. But today we're gonna actually start talking about networking, a very important concept within app development, within a lot of like any kind of development, really. But yeah, let's get right into it. So just a couple of announcements. So okay, the P5 deadline was pushed back like it was originally Monday, so it's due Tuesday. Yeah, not like this Tuesday. Because yeah, we uploaded lectures pretty late last week, so it's due tomorrow, actually. Yeah. Um, and yeah, spring break is near. Hope you guys are excited for that. And also if you guys have signed up for mentor mini stuff for the course, please make sure to meet up with your mentee or mentor before going to spring break. That way you guys could like communicate. If you haven't reached out yet, make sure to reach out. And yeah, let's jump right into it. So we actually want to showcase some cool apps that some of our students have made. So let me go into that. So this is P4. This is the project due last week. This is Yichen's. So they implemented this cool like playlist app. And actually let me increase this. So it's really nice because they actually added like the swipe to delete. And so it like deletes, and you could also go into it, change the name of the song and stuff. If you click save, go back, it changed. And it also has pretty cool designs. I like the contrast with the back and like the album images. It's pretty cool. So, and also the font of like the text is also kind of cool with the neon. And another app that Andrew made, also equally cool. It's a dog list. You got a list of dogs, and they also have like a swipe to delete. You know, stuff that we don't really teach in the course, but that you could like explore. And they have cool pictures of dogs. You know, and yeah, basically all that is to these apps. They're really cool apps though, regardless. I think going forward throughout the weeks, we're going to be showcasing some cool apps that we go throughout that we see throughout grading. So expect that next Wednesday for Alden's lecture. But yeah, great job, guys. Great job to y'all. So going back to like our lecture, what exactly are we going to be talking about today? So we're going to be talking about networking, what that is, I guess how to use it. And HTTP requests are one way of like using networking. Response codes are things that tell us exactly how our servers interacted with our clients, whether or not we got that information that we wanted to. And JSONs are one way to format this data that we're going to be receiving from servers. So I guess to talk about a little bit more about what clients and servers are in networking. Networking basically connects your app to the internet. So a lot of the issues, or actually, let me go into it. So why exactly do we want to connect our app to the internet? So this is just some examples of like what networking could be. So for Facebook, networking could be like getting that information from a server and presenting it to your phone. This information isn't stored on your phone locally. It's actually pulled from a different server. There are requests that have been made from your phone to the server where that holds all of these posts that present to you all of, like the posts, all the images, all the text that isn't locally stored on your phone. Same thing with emails. Emails are something that always change. You get new emails every day, and that information of emails isn't stored directly on your phone, but rather it's on a different server that you request to get emails from. So every day your phone's making requests to many, many different websites, many different products, and we interact with these things every day. Like what makes app development so cool is that you're actually able to facilitate these kinds of interactions between you and like a server. Like say like in the server you could also pull information from other people's like profiles, from other people's posts. And so networking actually gives us like this interactive feature to app development that's so like sought out when we create these kinds of apps. To go into a bit more. So we have our email. The way like this information could be presented on our phones. Like say we were running a demo that was like Gmail, and we want to create the data that would hold these emails. We could create it by like naming these two like things, all these emails, something like email 1, email 2, email 3, whatever. And this would be how like that email object is kind of stored, like if we were to make these email objects ourselves, we would say like we would give it a title, contents, is starred, properties, and then to actually give our table view, because that's a table view, to give our table view that information that we're trying to present, we would put all of those emails within like an emails array. And then we would say, okay, table view, here's the data that you've been requesting from me. This is me providing it to you. So this is an example of like how we would implement, I guess, Gmail without networking, which is pretty bad because we wouldn't want all of these emails to be stored within our phone like locally, since they take up a lot of space. We wouldn't be able to like reload, we wouldn't be able to reload new emails since this information is just static, and we just wouldn't have that interaction that we would want, say, to like send an email to like another person. Like if I want to create an email and send it to somebody else, I have to use some form of networking to communicate between these two phones, these two email accounts. So how exactly have we so far been getting information for our UI table and UI collection view? So like I said earlier, we created like an email model that stored all of these emails. We created an array of email objects, and we would tell the table view or collection view, here's the data that I created. This is how you use it. We saw it within our contacts demo, contacts table view demo, where we had like a list of contact objects that we then put into our table view. And we also saw it with the shapes demo, where we created these shape objects within our view controller, and then passed it to our collection view to load and like create the cells for. Some of you have been working on like your filter cells and stuff, and like your in P5 or yeah, P5. So so all this information we typically don't want to create statically within our device. We want to pull this information from somewhere else. That way we could always like keep updating the information presented on our phones. We could always get new emails, we could always get new posts, and we could also like publish like new things if we wanted to. And that way other people could see the things that we publish, because you can't really show another person like the shapes that were on your phone during the collection view demo. That's only your shapes. You can't really share that with anybody. So yeah, like just to rehash some of the issues that come with like actually defining the data within our phone and then running our apps using that data. That data like has to be defined. Any updates to this data like would have to like make your phone or app like rerun your you would have to rerun your app in order to actually get that data update to occur. And data is not able to be shared, so you can't really share like this data that you would have created within your collection views or table views. And so these are the things that we want to fix. So how exactly do we actually fix these things? Let's do networking. So how do we actually connect our apps to the internet? We have these things called HTTP requests. So these requests are a way for our servers to communicate with our clients through the internet. And it's like this is where the sense of the word like cloud information, like passing things through the cloud, like kind of comes into play, because these servers like exist in real life. Like these servers are somewhere like maybe in like New Jersey or like California, where like they store all the information for our like profiles or whatever within Instagram, or like songs on Spotify. So all that information that we see on our phones, like through apps, is like stored somewhere, like physically. It's just that it's not stored on our devices. It's stored on a server. And if we ever want to retrieve this information, like retrieve like some mail for that day, like if I scroll down on Gmail, like I could get like a refresh icon that will like basically put out a request to like bring me all the new emails that I have. I do that through communication between the client and the server. So the client puts in a request to the server asking it, hey, I want to get like this kind of information. Can you bring it back to me? And the server gives some response. So this is kind of the concept that we're going to be working with today: clients and servers. Clients are usually like your phones, and servers you could imagine as like this huge like chunk of hardware. But servers could also be other phones. Like say you were trying to like you're trying to like refresh some messages, maybe like you're trying to like refresh the page that has messages that you might be sharing with like a friend. Then you're going to be asking your friend's phone, hey, can you pass me the information that that is on your phone locally, like the texts that are on your phone. And the client, your phone will be like, will retrieve that information from your friend's phone. And this is going to be like the transmission, I guess, of information between your client and server. In this case, the client being your phone and then the server being your other friend's phone. But you could think about client server interaction as like the client being your device, the device that you're operating with, and the server being just like some other device, other hardware that exists somewhere in the world. So just to go into what the internet is a bit, the internet is like a network that allows computers to communicate with each other. Clients are those things that call on some other like hardware to get something, and then servers, like kind of how the name suggests, actually give that client, they serve that client with the information that they're requesting. And one way to actually facilitate this kind of transmission of data is through URLs, which stand for Uniform Resource Locators. So a URL, kind of like the one depicted here, is something that we use nearly every day. We have like the HTTP and then the www.example, the 80, the stuff like the ports and stuff. All of this corresponds to us asking something else for information. Usually when you go onto Google, you might like Google some like keyword, right? And that what's generated after that is some URL that will take in that information that you put in, like the string that you're trying to look up, and it will pass it into the URL, and then that URL is basically a request sent to Google, sent to one of Google's servers to give you the information that you're expecting back. Like, say you're searching up like dogs on Google, and the information that you're trying to get back are like pictures of dogs. So we're going to deconstruct this URL a bit to kind of go into depth on how this actually works hand in hand to give you that information. So starting off with HTTP. So HTTP, like this, the beginning is not that important, but it's basically like the way your data is like transmitted. So it could either be HTTP or HTTPS. Yeah. So then comes the domain name. The domain name is like, you could think of as like a street address. So you might live on like some 240 East Westfield Ave or something, but the domain name basically tells you like the location, the street name of where you're trying to go to. And then once you're on that street, you want to know exactly like which, I guess, number house you're trying to get to, right? So that's where the port comes into play. The port tells you exactly like which house, which part of that street you want to go to. Like say like you lived on the street like example.com, and at port like 1 was like a Pizza Hut or something. At port 2 was like a barber shop. Port 3 is like a salon. Like every port is going to have a different function. And so in this example, the port that we want to go to is 80. So when I say like I'm at this domain and I'm going to port like 80, I'm saying I want my URL to do a specific thing. It has a specific function. In this case, that specific function is tied to the 80 that I put in to my domain. Like my domain could have many different parts to it. Like it could have like different functions that I would want it to accomplish, but the port is going to tell me exactly which thing I want it to do. And then after the port, we're usually given like a path to like the file that we're looking for. So if we're looking for some information, then this is going to be that file that we're going to try to get to. Say for example, like when I'm Googling dogs, like the path to my file is going to give me like an HTML file that tells me like that shows me the information of like my dog images. Like if you type in anything at Google, like it'll show you like a new web page that has like the relevant information to like the thing that you're trying to Google. And parameters could be anything that your website, that the requests you're making might require. So like going back to the Google search, for any Google search, it needs to have like something that you're trying to look for. It needs to have like that key. In this case, the key being like that text, the long like text that you might be putting into your Google search bar. So not all websites need that. Like some websites just load automatically. Like if you just type in like google.com, like it'll give you information, like it'll give you like the Google homepage with like the search bar. But if you're trying to actually look for like pictures of dogs, you have to put in like the dog string within like this URL to search up those images that you want. And so this is going to be parameters are really important for get requests, because usually when we're trying to get something, we're specifying some kind of information that our server needs in order to get that information that we want. Oh, and the last thing is like anchors. Anchors basically tell you like which part of the page you want to be on for a URL. So maybe like when you're searching up dogs, you want to like go to like the halfway point between like the top and the bottom of the page. Then you could set an anchor to like to your URL to make sure that every time you go to that URL, it goes to that like section of the screen of the page that you want it to be at. But it's not like totally that important. So, and these are the different kinds of HTTP requests that we might have. So we have like get, post, delete requests. These are the main ones that we're going to be working with. These are just the ways that we could basically communicate with our server. You know, we could get information from our server. Say like for Instagram, like I'm swiping up on like the refresh on my refresh homepage, like I'm trying to refresh the information there. That would be a get request because I'm basically asking Instagram to send me the most up-to-date information on my friend's posts. And then the post request, of course, like if you want to post some kind of like, if you want to create a post on Instagram, then you put in like, you give Instagram like an image that you want to post along with the string. And then you tell Instagram, okay, post this, like post these images and strings together. And that would be a post request. And that way, like everybody on the Instagram network would be able to see that image and like text that you posted with your posts. And then for every like thing that we create, we also want to make sure that we are able to like delete it. You know, for any post, you could delete your post for any like for any playlist that you create on Spotify, for example, you could create it, you could add songs to it, meaning you could change the data, and then you could like delete the playlist if you want. That way nobody could see your playlist or whatever if you want to hide your songs. And these are basically like the only three requests that we're going to be working with in this class. There are a lot more, there are many more, but this is the main three that we're going to be implementing with every model that we work with within our apps. So yeah, just to kind of rehash what I just said, get is to retrieve things from the server. Post is to create or update like the model that we're talking about. Like if I have a playlist of songs, then I want to add a song to my playlist, then I'm gonna tell the server, hey, this is the song that I want to add. Change the data of my playlist so that it includes this song. And delete would just tell that data to delete, or delete would just tell the server like, hey, I don't want this playlist no more. Like delete my playlist because I want it. And there's this paradigm called CRUD that stands for create, retrieve, update, and delete. And basically, this idea, this concept is used for whenever we create models within our app. So, you know, when we add networking, like networking is a very like dangerous kind of thing to play with, because when you allow other people to post and delete, or if you allow other people to like post and like update things on their network on your phone on your app, you also want to make sure that they're able to delete things, because if they can't delete things, then say they post something like accidentally like one night, and then like they wake up and they're like, okay, why did I say that? Like I really want to delete it, and they can't delete it. Like that's gonna be an issue. You know, that's gonna be an issue for the users of your app. They're gonna be unhappy. And so whenever you're implementing any model and trying to like add some kind of networking to that model, like a post or like a playlist kind of concept, like idea, then you want to make sure that for any model that you have, you're able to create, retrieve, update, and delete that model. So we're gonna be going into this. We're gonna be going into a lot more depth with this, like when we actually go into our demo on Wednesday. But keep this in the back of your head. And stands for CRUD. But yeah, so clients, you know, request information from a server. They ask the server, hey, this is what I'm looking to get, and I want you to provide it to me. And the server gives us some response. You know, that response, however, has to be read in some way. Like our phone, our like the response is kind of unexpected, in that like it's like very abstract the way we've been talking about these responses. Like what exactly is in my response? Um, but first let's go into a bit more on how these responses are like handled. And every time we actually ask our servers for a response, they give us a response code. So these response codes could range from like 100 to I think like 500 or so. And basically that first number within our response could indicates the category for our response, whether or not it's like a successful response or like a failure, like it didn't the request that we're trying to put in didn't go through. And the last two indicate the code for like that response that we might have. Like if you have an error, if it's like a 400, then you want to know what kind of error you're getting. Like, is it is it my fault? Is it the server's fault? Is it because I had the wrong URL? Is it because like the website's out of date or something? So these response codes are very helpful when we're trying to say like, okay, this is the reason that your website failed. This is the reason that the GET request that you tried putting in failed. And it's because of like this specific reason. So these are some of the codes that these are what some of the categories represent within our requests that we might have. So one is usually informational. So when the code starts with a one, it usually means like, oh, the website's like out of date, or like, you know, something. You might want to update like your website information. You might want to update like your website backend stuff. That would usually fall under the one category because it's not like it's like a warning error. It's like a warning message almost. Like it doesn't affect the way your website runs, but it's just like something that you might want to know. And then two is something that we're always like happy about. You know, we're always like looking forward to like getting a 200 like response because that means that your thing works and there's nothing preventing you from getting that information that you want. A 300 basically means that the URL that you're going to is going somewhere else. We don't really have to pay attention to that much since we don't get those a lot. But a 400 is bad. That's probably the worst one because a client error means that that's our fault. We're doing something wrong. So say for example, like a 404 error, like a 404 error is usually because we typed something wrong within our URL. So that's something that we have to check ourselves. And then a 500 server error would just basically mean like it's not our fault, it's the backend's fault. So their 500 errors are nice because usually, or there's sometimes nice because that means that it's not your fault, it's like the backend person's fault of whoever you're working with. Say for example, you have like, well, actually, by the end of this course, we're going to be having this hack challenge where you guys get to work with like other backend members to create an app that you guys ideate. And something you might get one of these errors, like a 400 or 500 server error. And if it's a 500, you could basically say, hey, like something's going wrong with like the backend, like you got to tell me like what's going on to backend. And then a 400 level error would be something like, oh, like my URL, like my endpoint is like incorrect. I should probably change it on my end. So these errors are very useful for when you're trying to debug your code for your hack challenge. Like say you have some errors and then you look at these, you can refer back to these slides and be like, okay, it's this kind of error. So I know it's like either my fault or my partner's fault. But yeah, so yeah, I'm gonna go into a bit more about like these 400 level errors and 500 level errors since they're the most predominant when we're trying to debug our code. So a 400 error is usually like just a bad request, like the URL that you're trying to get to just isn't working for some reason. 401 means that you're going to a page that you're not allowed to be at. Say for example, you don't have like some privileges to access this page. You're not like an admin to access the page or whatever. 402 is like you have to pay to get to that web page. So it's usually like paid service to get to like a specific web page. 403 means like you also can't access it. But usually it means like you can't access it because like nobody could access it or something like that. But basically 401 and 403 are very similar. And then 404 is the one where it's like, okay, that's like you type something wrong usually because it literally like can't even give you like a clear error. It's just like you can't find this web page that you're trying to get at, which could mean that the endpoint that you're trying to use, the URL that you're trying to use is like outdated, or it could just mean that like you typed it wrong. So it's one of the two usually. And then some just like common errors usually involve, 200 is like, okay, like it's great. You were able to get the data. 301 means that your data was like just moved, the website like moved somewhere else. 403 is like, you can't can't access this because you're not allowed to. 404, it's like you can't find it. 410 means that the website like might have gotten like totally deleted, like it's not there anymore. And 500 is like some error on backend's fault. Just to kind of, I guess, show like what 404 error would look like. So I just typed this like URL, like 404, and I'm getting this error because like I tried looking up like this like random like string that doesn't work because it like this page just doesn't exist. So I typed something out wrong basically. So that's why you get a 404. But whenever it starts with a 4, that's usually like our fault. So always make sure to check out to recheck your strings, your endpoints, your URLs. Uh, and yeah, so back to the question, like how we actually communicate with these servers. Like we get these responses, we have like these response codes that tell us whether or not our data like got to us successfully. But then how do we actually manage that data that we got, Because a server isn't going to know that you have like a post class that you made that you want to retrieve data for. It's not going to know that. It's just going to give you what's basically like you could interpret as like a string. Um, and this string is a JSON. Like a JSON is basically why is this wait? I don't like this. Okay. A JSON is basically like the standard format for how your information is received. So JSONs have key value pairs. They're kind of like dictionaries. Like you'll see on the next slide, like oh, they look like that. And as you can see, a JSON contains the keys are always strings. So in this case, the key is like name, course number, instructors, all those things, all those keys, all those things to the left of the colon are always going to be strings. And the values on the right side are always going to be some like kind of object. They could either be strings, spools, arrays, or null. And those are the only kinds of values that they could hold. So like when I have name within my JSON, it maps to an intro to iOS 11 string. When I have like course number, I can map that to an int. And I could also have like this array, like a little array of like a mini almost, or not mini JSON object. Well, like mini JSON object within my JSON object here. I could have like this array instructors that gives me even more information that I'm gonna have to work with. And the way we actually like use this stuff, we have this thing in Swift that will automatically like decode a JSON. It's literally called like a JSON decoder. It's stuff that Swift provides us. And this JSON decoder is what we use to actually extract this information. Because right now, like this intro to iOS development string, maybe we want it to like map to like some object that we have within our end, within our like our within our app. Like maybe we want to pass like we're not always going to be passing like strings, ints, and arrays. We might be passing like to the server like our own interpretation of these objects. So we could have like a post. We could have like Spotify has like a song object. It doesn't pass in like an image, a string, or the album titles. Like it doesn't pass it all like separately. It creates like a song object and it passes it to the server. So when Spotify asks, when the apps asks like for this information back, it returns to it like a kind of like object that has these parameters, that has like this parameter like string, album cover, like album name. And so we have to find a way to actually like extract that object. And we do that using like this built-in decoder that's called like a JSON decoder. Um, but I hope this like interpretation, like this layout kind of makes sense because it's almost like a dictionary. Like it basically is a dictionary. Like you just put in like name into this JSON and it'll give you like that string. You put in like instructors and it'll give you that array of other JSON objects. And so this information is like pretty easily accessible once you like decode it. And so next time in demo, we're going to be working on actually processing these responses like through a JSON, how we could actually extract this information through a JSON. And I think that's it. Yeah. So yeah, I went through that a bit quick. Does anybody have any questions on on what we just talked about today? Yeah. like the URL stuff. So yeah, I should have put in more code here. But basically, like when you're actually making these networking requests, the most important part is to actually like write this URL. So you're going to be given, usually when you're working with a backend member, like somebody on backend, they're going to give you like a URL that's basically is going to be where the JSON information is. So it's going to be like a URL where if you put it into your own web browser, it'll show you like this like screen of like just random text that is a JSON. It's a JSON file. So all the information that you're going to want is going to be basically put into a URL. Imagine like the classes, like the contacts, the shapes, all that information, all those arrays, all those data, all that data that you had is now put into like a URL. So what's going to be important moving forward is you being able to like type the URL correctly, because there might be errors with that. And just communicating with backend to make sure that those URLs that your data is supposed to be coming from like actually work. Yeah, like the backend works by having like a server, and then they give you like you can think of the URL as like a key to access like that server. So the URL like is gonna ask probably for some parameters that are very specific to that URL, like almost like just like accessing like a safe. Like it's gonna like the URL is gonna have to have like some kind of key that it knows that nobody else would know. In that way, like your data isn't like compromised on your website. Any other questions?